Right now, 3I Atlas, a fragment of interstellar debris hurtling at over 90,000 kilometers per hour, is crossing the outer rim of our solar system. Through the infrared eyes of the James Webb Space Telescope, this alien wanderer glows with signatures never before seen in known comets. Its dust is older than the Sun itself, forged in another star's death, and its secrets may rewrite our understanding of how life's ingredients first began. At the edge of darkness, where the faintest light still whispers across billions of kilometers, an anomaly drifts between suns. It moves at nearly 90,000 kilometers per hour, faster than any comet born within our solar nursery. Its name, 3I Atlas, the third confirmed visitor from another star system. Through telescopes around the world, its path appears as a faint incision of motion against the stillness of the cosmos. A silent traveler, untouched by time, crossing the void on a trajectory that will never return. For generations, the idea of interstellar wanderers lived only in theory, fragments torn from their birth systems by gravitational chaos, destined to drift between stars. The detection of Oumuamua in 2017 and 2I Borisov in 2019 proved that these voyages were real. But 3 Atlas, discovered in 2024, would become something more. Unlike its predecessors, it carried an unbroken signature of its alien chemistry, a message, written in dust and ice, from a sun that died long before ours was born. Through the infrared vision of the James Webb Space Telescope, the veil began to lift. Its mirror, cooled to just 40 Kelvin, captured faint reflections of light emitted from 3I Atlas's frozen surface. The data was astonishing, a spectral pattern unfamiliar to any catalogued body in the solar system. Instead of the typical mix of water ice and silicates, Webb recorded strong bands of complex carbon compounds, long-chain hydrocarbons intertwined with mineral crystals. These were the byproducts of stellar death and rebirth, fragments of worlds that had once orbited another star. Each photon collected by Webb carried a story billions of years old. The object's reddish hue suggested the presence of tholins, organic residues formed under cosmic radiation. Within its frozen mantle, volatile gases were trapped like time capsules from a distant epoch, their isotopic ratios pointing to a colder, dimmer star. 3 Atlas was not merely a comet. It was a geological archive from beyond our sun's domain. As scientists decoded the data, a realization emerged. This object's chemical fingerprint bore no resemblance to any known solar body. Its atomic ratios hinted at an entirely different environment of formation, one perhaps older, more stable, or more violent. It was evidence of alien chemistry at work, an echo of creation from a star that no longer shines. The implications rippled through the astrophysical community. Here was proof that the ingredients for complexity, for molecules, for life's precursors, were not confined to one planetary system. They were universal, scattered like seeds across the dark interstellar fields. 3I Atlas was both relic and messenger, carrying the molecular whispers of another sun into our reach. As it hurtled past Neptune's orbit, fading slowly into the cold, the data lingered. Pages of cosmic memory preserved in digital form. In the faint infrared glow of a dying signal, humanity glimpsed not just another object, but another origin story. At 1.5 million kilometers from Earth, the James Webb Space Telescope hangs in the stillness of the L2 Lagrange point, a sentinel balance between sunlight and shadow. Within its gold-plated mirrors, photons older than humanity itself are trapped, dissected, and transformed into data. One of those signals came from a visitor no one expected, a dim, red-tinted object gliding silently beyond Jupiter's orbit. Its name was 3I Atlas. Its light told a story that no known comet had ever told before. The mid-infrared instrument, or MIRI, recorded its faint thermal breath and mere whispers between 36 and 44 Kelvin. Yet within those degrees, the telescope revealed structure, complexity, and memory. Webb's sensors traced subtle thermal fluctuations that mapped its surface in spectral color. A thin shell of dark organic carbon overlaying crystalline silicates that had formed under immense heat. The combination was impossible for a comet born within our solar nursery. It was the fingerprint of another sun's history. Every photon, every oscillation, spoke of elemental ancestry. The silicates glistened with a purity that implied slow formation in a disk of cooled stellar debris, the kind found near a star's dying phase. Beneath that shell of frozen carbon, ratios of deuterium to hydrogen soared far above interstellar norms. This minute detail, invisible to human eyes, revealed something extraordinary. 3I Atlas was forged in an environment colder and older than the one that birthed our own planets. It was likely shaped in the outer mantle of a dying star, perhaps a red giant that shed its final layers into the void. As data streamed across the deep space network, scientists began to see patterns too symmetrical to ignore. Layered composition, isotopic isolation, and organic crust, together they painted a portrait of resilience. This fragment had endured radiation storms, gravitational ejections, and epochs of interstellar frost. It was a survivor from a system long extinguished, drifting alone for millions of years before crossing the path of our telescopes. But its message went deeper than geology. Its chemical ratios hinted at processes that challenged our understanding of stellar evolution. Could dying stars seed interstellar space with complex carbon before collapsing? Could their outer shells act as crucibles for molecules that precede life? Webb's instruments, designed to look back in time, had stumbled upon a living relic, not of biology, but of chemistry's first whispers toward complexity. In the dim glow of its spectrum, 3I Atlas became a paradox. It was both cold and full of heat-borne minerals, ancient yet strangely preserved. Its silence spoke of violent birth, its stillness of endless motion. And through Webb's eyes, humanity watched not just a comet, but a cosmic fossil, the frozen autobiography of another sun's death. At 43 astronomical units from the sun, 3I Atlas glides through a silence colder than absolute memory. Its surface, a thin crust of carbon and glassy ice, catches the faint light of distant stars, reflecting photons that have traveled centuries. Through the deep gaze of the James Webb Space Telescope, those photons become data, and that data becomes revelation. Hidden in the spectral lines is a whisper, the chemistry of life carried across interstellar space. The models were clear. Beneath the upper frost, Webb detected long-chain hydrocarbons, molecular architectures of carbon and hydrogen, precursors to amino acids. These chains are the scaffolds upon which biology builds itself, the alphabet of organic evolution. They were not fleeting traces. They were dense, layered, and ancient. Somehow these fragile molecules had survived the ultraviolet onslaught of deep space, the bombardment of cosmic rays, and the erosion of eons drifting between stars. How could life's potential remain intact for so long in such hostility? The answer lay in the structure itself. Each hydrocarbon was entombed within microscopic grains of silicate dust, shielded like messages, encased in glass. These mineral shells, remnants of a dead system's birth disk, preserved the organic molecules through radiation and time. They were cosmic capsules, traveling for perhaps 1 billion years before crossing our path. This discovery reignited one of humanity's oldest and most daring hypotheses, panspermia. The idea that life, or its raw ingredients, migrates across the galaxy, seeded by comets, asteroids, and interstellar debris. If 3I Atlas could carry organics forged under an alien sun, could similar objects have once delivered the same building blocks to the young Earth? Every element pointed to a possibility, both scientific and philosophical. The carbon chains mirrored those found in meteorites that have fallen onto our planet. The isotopic ratios of nitrogen and hydrogen matched those of amino acids detected in ancient Antarctic ice. The chemistry was not local, it was universal. Life's alphabet, it seemed, was not invented here. It was borrowed. But 3I Atlas's signal contained more than confirmation. It contained variation. Subtle differences in molecular branching and bond energy suggested environmental conditions unknown in our solar chemistry. These deviations hinted at organic pathways shaped by alien stars, processes that may have unfolded in temperatures and pressures beyond anything Earth has ever known. Within these distortions lay the possibility of entirely new biochemistries, unbound by the rules of terrestrial evolution. As the spectral reconstructions deepened, Webb's instruments had effectively read a chemical message written billions of years ago, a script from a time before our sun existed, before Earth was even dust. It was a note in a bottle cast across the galactic sea, bearing proof that the raw code of life is not a singular phenomenon, but a cosmic language written everywhere matter can cool. If such molecules can endure across the emptiness between stars, if they can cross gulfs of radiation and gravity, then perhaps the beginnings of life are not exceptional, but inevitable. Across the vacuum of interstellar space, 3I Atlas drifts, a single grain of memory suspended in an ocean of silence. Within its spectral signature lies a record older than humanity, a chemical archive written by forces that shaped not just one world, but many. When the James Webb Space Telescope dissected its light, the data revealed a pattern of extraordinary familiarity. Ratios of magnesium silicates, olivine, and pyroxene, minerals that form the rocky foundations of planets, matched those found within Earth's own crust. Yet this fragment did not belong to our Sun's family. It was born beneath another star's glow. The implications were profound. If an alien system, formed under entirely different stellar conditions, produced the same elemental compounds, then perhaps the architecture of planetary creation is not random at all. The same choreography of dust and gas, collapsing, condensing, colliding, may be playing out everywhere, governed by the same mathematical rhythm. Across billions of light-years, the same atomic harmonies might be composing worlds unseen, repeating like verses in a universal symphony. But Webb's infrared instruments detected dissonance beneath that symmetry. The isotopic ratios were wrong, the fingerprints of chaos imprinted within order. The abundance of oxygen-17 and carbon-13 was far beyond solar norms, suggesting an environment touched by cataclysm. Somewhere in its history, 3I Atlas had been shaped not only by creation, but by destruction. Perhaps it formed in the debris of a supernova, its minerals condensed from the ashes of an exploded sun. Or perhaps it was cast adrift by the violent migration of gas giants, their gravitational tides scattering nascent worlds like shards of glass. Each hypothesis carried a paradox. The object's crystalline silicates required slow, gentle heating over millions of years, conditions of stability and balance. Yet its isotopic signatures screamed of sudden violence, of stellar fire and gravitational war. How could both stories be true? The answer might lie in the duality of all creation. Destruction, in cosmic terms, is not an end. It is a mechanism. The collapse of one star seeds the birth of another. The scattering of one world sows the ingredients for countless more. In 3I Atlas, scientists found the cosmic equivalent of architectural blueprints rewritten by fire. Its layered dust grains preserved the molecular hieroglyphs of two processes, chaos and order, interwoven into one. To study it is to glimpse the recursive logic of the universe itself, systems rising, collapsing and forming anew, all governed by the same invisible constants. Webb's data, precise yet poetic, spoke of a cosmos that builds through breaking. Each particle in 3I Atlas testifies to this balance, the quiet equilibrium between the forces that construct and the forces that undo. The same symmetry that gives rise to planetary disks may also drive their ruin. In that duality lies the essence of cosmic architecture. Everything that exists is built upon what was once destroyed. And so, in a single drifting fragment, humanity sees a reflection of its own origin, a pattern that echoes from the smallest grain of dust to the largest galaxy cluster. 400 million kilometers from the sun, a fragment of ancient ice drifts through the void. Indifferent, silent yet bearing a story older than time. Designated 3I Atlas, it is the third known interstellar object to enter our cosmic neighborhood. To most eyes, it is little more than a frozen ember of dust. But through the gaze of the James Webb Space Telescope, it becomes something else entirely. A messenger from beyond the